So projectile motion. When an object is thrown into the air, it is a projectile. Basically, any object free fall is considered a projectile. So there's three possible situations. Thrown vertically up and it comes down. We already did that. That's when we toss up a ball, it comes down. Thrown horizontally, so just straight across. Or thrown at an angle, like this or like this, right? Okay? So first we'll just do thrown horizontally. So, object that has both the object has both vertical and horizontal component, just like we've been looking at with our 2D vectors. So we're going to take our concepts of 2D vectors and apply them now to this. These two components are independent of each other except for the time of motion. The horizontal motion is uniform motion, therefore we can use V is equal to D over T. So before we said, okay, we are steering clear of this formula because when we're dealing with acceleration we don't use this, but for these questions we do use it because horizontal motion is just in uniform, we can use this formula again. The vertical motion is uniformly accelerated motion. So we always assume that our VI is 0 meters per second. Because the object has no vertical velocity at that very instant in time it's released. Acceleration is always due to gravity. We just refer to it as positive 9.81 because it's relatively, we know it's going down, so we just leave it as a positive. So, for these questions, we can use any of our formulas for acceleration like we were using before. So when we're trying to figure out everything, we can use our VF, VI, T, D, and A. So we need to write out which ones do we know and figure out what formula do we use and then go forward. So just like we were doing with those acceleration questions. So when we think about actually sending out a projectile, it has a forward motion, but it also has like a horizontal, or this is the horizontal vector, but it also has a vertical vector. So here we have our V, X. So our X, if we were doing graphing, would be as so. But our V, Y at this point in time is 0 meters per second. Now, as this is launched off, it has a trajectory path. And here I can say that my Vx is still going horizontal. But now I will have a Vy here, going down a bit. And that can be calculated using our acceleration. Okay, again, follow the trajectory. And I will have my Vx again, and my Vy. At this point, my Vy will probably be bigger than at this point because I'm accelerating down. And here, my Vx over, and depending if it's hit the ground or not, we'll have our Vy. So you can flip the page. Okay, so let's do a practice problem. An object is thrown horizontally with a velocity of 20 meters per second from the top of a building 50 meters tall. How far from the base of the building did the object hit the ground? So, the first thing in these steps is to draw a picture, because it will help you conceptualize what's vertical and what's horizontal. What's the first step? What's the first step? What's the first step? Draw a picture. Yeah.
You did that too?
Everybody say it. What's the first step?
Draw a picture.
I'm going to come back, and you better ready to tell me what the first step is. More enthusiastically.
First step. First step.
What's the first step?
Draw a picture. Draw a picture.
Draw a picture.
You guys are lame today.
You guys disappointed me. Disappointed.
Okay, let's draw a picture. So,
He's gonna watch the video after.
what did you do?
Why are you looking at me?
So, my building is D is equal to 50 meters. Okay, my building. Now, an object, I'm just going to represent it as a ball, is thrown off the building. And I'm going to draw on its vector as Vx is equal to 20 meters per second. Because I know that off of the building, it has a horizontal velocity of 20 meters per second. That's why I drew a horizontal line. Okay, now we know that it's going to have a trajectory and have an arc-like fall to the ground. So this is asking us how far from the base of the building did the object hit the ground? So it's asking me to find this distance here. So now, I've been given a D and I'm trying to figure out a D. So what do I do? Well, I need to divide my information up into two groupings. One is vertical, one's horizontal. So let's have two groups of information. Our vertical information and our horizontal information. The only thing that stays the same across the board is time, okay? So you can write in here, time is same for both. So you can use the same time because the same time that it took to go horizontal will be the same time vertical, okay? All right, so vertical information. I know my A is 9.81 meters per second squared. I know my VI for my vertical is 0 meters per second. I know my vertical distance is 50 meters. What I know for my horizontal, I know that my V is equal to 20 meters per second, and I'm trying to find out D. Because I'm trying to find my horizontal distance. Okay, if I use the formula V is equal to D over T, D is equal to V times T, what am I missing from this information in order to do this formula? T. I'm missing T. But, as I told you, time is the same for both. So, I can find out my time using my vertical information and then apply it to my horizontal information. So, now on this side, I'm going to say T is equal to question mark. So if you like using, where did it go? These things, if you want to have these like with you while you're doing it, you can come and grab one of these rather than taking out your notes from that section, and then you can fill it in. I know some of you found that helpful, so you can grab one of those or you can use your notes. Also take out your formula sheets. Okay, so take out having your formula sheets out with you. If you use one of these, just be comfortable using your formula sheet as well. So if I look, the formula that I need to use is D is equal to BIT plus half AT squared. Is my formula that fits with everything I have available. In order to simplify and rearrange, excuse me, I'm just going to cross this out because that's 0. So D is equal to half AT squared. This rearranged is T is equal to the square root of 2D over A. I'm not going to spend much time anymore explaining how I rearrange things because that's a skill that we need to be able to apply ourselves. Okay. So now I can put that in. So you should get something like 3.19 seconds. So now I can take that and apply it to this side of my information because, like I said, time